Thanks, Mark. You already know all this stuff. All right, so for the massive crowd that's here, I'm going to be talking about just little tips and tricks for getting your SQL to be faster and better. So this is a short version of a couple decks of slides that I do called Join Fu. And I'm a huge Kung Fu fan. I don't do Kung Fu. I don't know really much anything about it. I just like the movies. So Join Fu, it's kind of an art form. It's a way of rewriting your SQL so that you can get better and faster SQL code, more explicit SQL code. So this is a set of tips and tricks for doing that. It builds on the foundation of the schema. So go get your schema in order and your indexing strategies and all that, your data type small, all that kind of stuff. Know the storage engines correctly, and then start doing this stuff. So we're going to talk about some of these strategies. Guidelines. Anytime you do any select expression on the database, I guarantee there's always about 5 different ways to rewrite the select expression, and all of them are going to have different query execution plans. So some of the slides are going to show you just little rewrites that you can do that you can get dramatically better performance out of your select expressions. Beware of join hints. In MySQL, you've got the straight join, which forces a join order. Then you've got use index, force index, and ignore index. These can be useful in certain times, but I say beware of them, because especially if you're working on a team with multiple developers that are changing SQL, and you put in a join hint somewhere, almost always you never end up telling the other people about it. And then a year later, when the data set grows by 10 times and you've just forced a bad query execution plan, you're like, why is this query it used to take 1 millisecond, now it's taking 10 seconds. And a lot of times it's because there's a join hint stuck in there that people forgot about. So just be careful about doing that. Also, if you can do something in a single SQL statement, that's not necessarily the best or fastest way to do it. One strategy is to break complex SQL statements into smaller ones, so just remember that. Try different variations on a theme and cut complex stuff into smaller chunks. It's more manageable and easier to wrap your brain around. And then always test and benchmark your stuff. So, anyone know what ANSI versus theta coding style is in SQL? Most people are used to, well, if you're in MySQL, a lot of people know the ANSI style, but if you're using other database systems that support the full theta syntax, you might be used to the comma type joins. So at the top is the ANSI style. It's where you explicitly state what you're joining together. Inner obviously is an optional word, but I put it in there just to be explicit. It also makes it easy, just double click on it, convert it into a left join. This on the bottom is the theta syntax. I'm not too fond of it for a couple reasons. These two things do the exact same, these two expressions produce the exact same result set. However, I think it's supremely easy with the theta style to leave off one of the join conditions in the where clause, and by doing so you do a full Cartesian product of the two tables. So it's just a lot easier to see where you're missing join conditions if you use the ANSI syntax. The other reason is that MySQL only supports a very small subset of theta, which is the cross join and the inner join. And so if you want to do an outer join, you have to use left or right join, and you have to explicitly state it. So I'd say just use one style, be explicit, always do the same thing. All right, so tip number 1. Index columns and functions. Acting on the index columns. They don't mix. So here we've got an index column which is called title in the film table. And these are, like I said, there's a million ways to do every single thing in SQL. These two things produce the exact same result set, but one of them has a dramatically different performance characteristic than the other. The first one, we're doing a where title like tr%, and then in the bottom one we're doing where the left 2 characters of the title are equal to tr. A lot of people assume that the bottom one is going to be faster than the top one because they think that the equality operator is faster than the like operator. That's not the case. The like operator actually just converts it into a range operation, greater than or equal, less than or equal. And this is just greater than or equal tr. So when you're not operating on an index column with a function, the index is able to be used by the optimizer in order to satisfy the select expression. If you do operate on the index column with a function, the optimizer can't use the index, and you've just basically nullified the effects of the index. So never operate on an index column with a function. There's almost always a way to rewrite the expression so that you isolate the index column on one side of the equation. Here's an example of removing a number of inefficiencies in a single SQL statement. So on the top, we have our original SQL select statement, which is select star from orders, where 2 days current date minus 2 days order created is less than or equal to 7. That'll give us the last 7 days of orders. Is that syntactically correct? Yes. Does it produce the last 7 days of orders? Yes. Will it perform well? Absolutely not. The reason is, last slide, I was operating on an index column with a function. There's a way to rewrite the expression so that we isolate the index column on one side of the equation and remove the functions around it. The minus interval 7 day is just an SQL construct that produces a constant expression. And then it's compared to the current day function, and then that constant is done on the range expression against the order created index. So at the top, we'd be doing a full table scan for every single time we call that select expression. This one, we'd be doing a range access strategy, which is highly optimized in MySQL. Next thing that's wrong with this is the current date function. So the current date function is something called a non-deterministic function. It means that if you pass the same parameters to the function, you're not guaranteed to get the same results back every time. So different examples of non-deterministic functions: rand, quite obviously, current date, current user, now, sys_time, all that kind of stuff. Anytime you use a non-deterministic function in the select expression, the query cache ignores your query. And so for this specific thing, let's say we have a data warehouse application. We've got a bunch of business analysts that are using this client-server application, and they're grabbing the last 7 days of orders. And the data in the application only changes every midnight. So there's an ETL process, extract, transform, load, loads in the last day's orders, and as business analysts do, what do? They sit and they hit F5, refresh all day long, right? Well, with this query is going to be reparsed, re-optimized, re-executed for every single time that the business analyst or pointy-haired boss is sitting there going F5. Just simply removing the current date non-deterministic function and replacing it with a constant in whatever programming language you want, now it's parsed, optimized, sent to the storage engine, packaged up into a result structure, put into the query cache, and then for every time they're hitting F5, then the query cache is just going to serve the result back, and it never has to be reparsed, optimized, sent to the storage engine, any of that stuff. It just goes directly from memory. And then the final thing is removing the select star. So Rails folks are notorious for this because of active record, but you always want to not use select star in your select expressions. Actually specify the fields that you want to use. So in our little business intelligence application, what if all they were really interested in for most of the stuff was order ID, customer ID, order total, and order created? Well, if I had select star, well, maybe we're bringing in a texty or a blobby order memo field that maybe averages a couple K. Well, now we're sending all that stuff over the wire. There's really no need to do so. And we might actually overflow the limit of the query cache allocation block size. And so it might not be able to go into the query cache. So always specify the fields that you're actually going to use instead of doing select star. It's very tempting to do select star. Just don't do it. All right. Second thing. So there were examples of rewriting stuff. Here we're going to talk about not thinking in terms of for each loops. So as programmers, we are trained to think in terms of iterators, for loops, while loops, all that kind of stuff. If you think in those terms when you're writing SQL, you're going to produce ineffective SQL, or at least inefficient SQL in MySQL. Other database servers, the optimizer can rewrite your crappy SQL into better SQL, but some of the MySQL optimizers' weaknesses manifest themselves in this specific situation. Here we're going to show the last payment information for each customer. There's the schema. If we think in terms of for each loops, the natural thought process results in this kind of query. And so here we're saying, okay, for each payment, I want to go and find the last date that the payment was made for that customer. And so it kind of results in, okay, we make the payment table, and then where, because we kind of equate where with like a for loop. We're iterating across the payments, and then for each one we're going and finding the maximum payment date. That's sort of like the process that we do. And this is what kind of shows up, and this is called a correlated subquery in the where clause. If you look at the query execution plan for it, kind of makes sense. Dependent subquery, okay. Rows, 15, that's not so bad. There's about 16,000 rows in the payment table. Makes sense because you haven't put a where condition that actually filters the data. You're just using a where condition that goes in a loop and goes and looks up the last payment date for the outer one. So it's called a correlated subquery because there's a correlation. P.customer ID refers to the outer result set, which is aliased as P, and then customer ID is the correlation. 623 rows is produced by this. We've got only 16,000 rows in the table, and it takes 1.03 seconds to complete. Why is this? How many queries is MySQL actually executing for this? Well, assuming this is the actual record count, which is not because it's NODB, and that's always an estimate for NODB, remember that. That would be doing 16,568 queries. If I had 1 million records in the table, 1,000,001 queries. 2 million, 2,000,001 queries. Not exactly a scalable way of doing your SQL. So what you want to do, well, first of all, okay, what if we had an index that's covering? So we had an index on customer ID, cool, but in our subquery we're using the maximum payment date and the customer ID. So what if we make a covering index? Is that going to have a good effect? Yes, absolutely. Cut the performance by 50%. Excellent. Right on. However, if we just do it in a set-based way, you can see that the performance benefits are quite a bit better than just simply adding a covering index. What we do here is instead of doing correlated subquery in the where clause, we move the subquery into the from clause. And so we think of two different sets of information. One set is the payment information. Another set of information is the customer ID and their maximum payment date. That's a set. We join those two sets using an inner join, and therefore we're doing two queries instead of 16,588. If we had 2 million records in the table, how many queries would this be doing? 2. That's scalable. All right? So this is a different way. You have to train yourself to think in terms of set-wise operators instead of iterating across things or doing while loops, for each loops. As programmers, we want to do that for each loop because it's just a natural way that we think. But in SQL, it's a set-based language. You have to see what's unioned, intersected between different sets of information. So as you can see, just rewriting things, remember I said everything can be done like a bunch of different ways. Just rewriting it to use a set-based approach went from 1.03 seconds to 0.03 seconds. Pretty big performance difference. Okay, working with mapping tables. So I did say this was join foo. We're going to be doing a lot of joins in these. All right, we're going to tell you how to do or conditions and and conditions across this relationship. So this is your typical many-to-many relationship with a tagging or folksonomy application. You've got a project table, you've got a tags table, and then you've got to relate the two, because a project can be related to many tags, and a tag can be attached to many projects. Okay, so how do we get all project names which are tagged with MySQL or PHP? It's pretty simple. Select from the project, join to the tag to project table, then join to the tag table. So we're going across here, we're joining across that relationship. Then in the where condition we go where the tag text is in is translated into an or. So in MySQL PHP, and produces it. We get a pretty good query execution plan, but that's really easy to do or conditions. What about and conditions? This is where we get a little more complicated. We want to grab all projects that are tagged with both storage engine and plugin. So we can't really use the in operator the same way that we could last time, because in is or, it's not and. And so one of the most typical examples that you'll see on like the forums and stuff of how to deal with this is using a subquery in the from clause, and then we basically take our last query. You'll notice that this right here is that right there. And then we tack on a group by clause and a having count star equal to the number of items in our in clause. And true, this produces the correct results. Then we tie it back to the projects just to get the name and stuff. However, if you look at the query execution plan, we've got a real big nasty show up by doing this. and that is this using temporary using file sort. So what we're doing in the previous query here is we've got a lookup into the tag text index, which is ordered by tag text, but we need, in order to join here, an index that is sorted by tag ID, not tag text. And so we need to make a little temporary area and resort the data so that we can join it correctly. Doing this using temporary using file sort, there's two status variables in the server that start incrementing. One is called created underscore temp underscore tables. One is created underscore temp underscore disk tables. The disk tables one is quite bad. You don't want to have those happening all the time. It's basically swapping out the disk and creating a MySim temporary table and then destroying it at the end of the connection. So if you can avoid using temporary using file sort, you should do so. So how can we rewrite the expression so that it returns the exact same thing but doesn't use this stuff? Well, you can use a cross-join technique. So instead of doing the group by and the having stuff, we use a cross-join technique where we do two little dives into the tag table. We alias them as T1 and T2, and then in our where expression, we say where T1.tagText equals plugin and T2.tagText equals storage engine. What this does, the green part, is essentially returns to the optimizer the tag IDs for the phrases plugin and storage engine. So the optimizer has those things, and they will be stored in T1.tagID and T2.tagID. We then just join from our original query the two copies of the relationship table, and we get rid of our group by and our having count star. We do constant lookups, instantaneous. Using index is shown in the extra column. That means that a covering index is being used for every single set of information in the query. We do references, which represent the joins into the tables, and that constant that is looked up in the tag table, you can see, is propagated through the join conditions. Get rid of temporary, get rid of file sort, executes in about 1/10 of the time. Another technique for dealing with ands. I said before, just because you can do it in a single SQL statement doesn't necessarily mean you should, right? In this previous one, the one that had the cross-join to two copies of the tags table, we could have broken that down into two queries, right? Go grab the tag IDs from the tag table where the tag text is in plugin and storage. That returns us those tag IDs, and then we can just plug those into a separate query. Will that work? Yes, absolutely. So we could have done with the cross join, or we could split it out into two queries. Either one is good. This one might be better in your environment, just totally depends on the application. Let's assume that the relationship table is updated, inserted, or deleted about 10 times more frequently than the base tags table. Makes sense, right? People are relating projects and tags a lot, but they're not necessarily adding tags a whole lot, or not as much as the relationship. So if we query this, there's a much more likely chance that the query cache is going to contain all that stuff, and it doesn't even need to be parsed or optimized.
You know what?
And so in our previous query where we had cross joins to the tag table, we were actually going into the storage engine and retrieving those values because we're joining to the tag table. Here we might actually be able to get all the information for that directly out of the query cache. So there's numerous ways to do things. Just splitting up the query can work quite a bit. If you have a long query, just splitting it up into different pieces. So always try different variations on the theme. Okay, so now we're going to do some more complex outer join stuff. We're going to try and get the tag phrases which are not related to any project. We're going to get the tag phrases which are not related to any project, or the tag phrases related to project number 75. And then we're going to get the tag phrases not related to project number 75 in order of complexity. So, getting the tag phrases which are not related to any project. Anyone who's worked with SQL a little bit should be familiar with the outer join. Just a left join onto the relationship table, and then in the where clause we add where the right side is null. And this will return all tags that are not related to a project. You'll see this little not exist pop up in the extra column of the execution plan, of the explain output. That is a very good optimization to look for. This is why I've highlighted it green instead of red. So, if this pops up, very good thing. If it disappears, not a good thing. So, this is the easy thing. Let's go to the next thing, which is get all tag phrases which are not related to project to any project, or the tag phrase is related to project number 75. So the only change I've made is I've added or t2p.project equals 75 to the query. But what happened? I got rid of my not exists. Because the optimizer goes, it's an or condition, I can't deal with that, that's too complex. So we have to figure out a way to get it back. But what is an or? It's a union. This and this, put them together. So we can write it as a union. We can take our original query that gets all the tags that are not related to any project, and we can union it against the tags that are related to project 75. Why do we use union all instead of union? It's a small optimization. Union actually does a implicit distinct, and so it'll go through and add uniqueness to the results. Why don't we need to do that here? Because tags that are not related to any projects certainly will not intersect with tags that are related to project 75. Okay, so it's just a small optimization there. I've color-coded so you can see what parts of the execution plan actually correspond. And what happened? We got our not exist back. And we're doing a simple constant dive into the tags table, or the relationship table, with a constant right here as project 75. So, just different ways of rewriting things, and you get your optimizations back. So always look at the query execution plans, always try and rewrite so that you get the most optimal query execution plan. All right, final slide. Trickiest part. Getting the tag phrases which are not related to project number 75. So, if we're like good SQL programmers, we take something that we know works and we just add to it. This is what happens. So we take the one that says tag phrases not related to any project, and we just add, and the project is 75. Makes sense, right? That's nod, yes. There's a problem with this. Syntactically, it's correct. Logically, it makes absolutely no sense whatsoever. The problem is most people, when they're programming, their first deal with this little tricky issue is they'll get the results and they'll go, oh, okay, I guess there's no tags not related to project 75. Because it returns an empty result and it's a syntactically valid SQL. It doesn't, yell at them for not having correct syntax. But this is logically wrong. And the reason is anytime you need to filter the right side of an outer join, you need to put the filter in the join condition, not the where condition. The where condition is done after the join is handled. So if we're filtering for projects not related to project 75, we need to put that filter in the actual join condition. Oh, this is what happens when you PDF export to from OpenOffice. You lose your transitions and stuff. My transition said moves this and line up to just below on. So you have to put that and in the join condition. Oh yeah. I had it on my next slide. So, all right, and so I just moved it from below where to above where. I get it back, and now I actually get 674 tags not related to project 75, which is the correct result, both logically and syntactically. So that's the trickiest part, is remembering that little thing. When you need to filter the right side of a left join before the join, like as the join is handled, you have to do it in the join condition and not in the where clause. Another thing you can't do in the theta style syntax, which is why ANSI style kicks theta style's ass. Anyway, that's it. Those are my little tricks and tips. There's lots more tricks and tips and stuff in the slides online. If you go to jpipes.com, all the slides are there. So, thanks. Any questions? Cool. Thanks.